The first quantum property exhibited by qubits that we will discuss is that of superposition. A classical bit can have value 0 or value 1. Qubits, on the other hand, can be 0, 1, or any combination, and there are infinitely many such combinations of these two values. When our qubit, or our system of multiple qubits, is in a combination of values, we say that it is in a superposition of these values. To make this a little less abstract, we will discuss what superposition looks like physically for a linear polarization encoded photonic qubit. These qubits either are horizontally polarized, vertically polarized, or in a combination of these two polarizations. So here, 0 could represent horizontal polarization, and 1 could represent vertical polarization, or vice versa. It doesn't matter which notational choice we make, as long as we are consistent. We have this awesome graphic on the right side of our slide, created by NIST, depicting superposition and foreshadowing our next quantum property. We see that the skateboarder is either at location 0, location 1, or anywhere between these two locations. However, when the eyeball appears and measures his location, he is exactly at 0 or exactly at 1. Which brings us to quantum measurement. Before measuring our superposition state, we can only know the probabilities of measuring the state at 0 and measuring the state at 1. When we do measure the superposition, we can only end up with value 0 or value 1. We can no longer be in a superposition of the two states. We are collapsing the superposition from being in a combination of multiple states into being in exactly one state. Essentially, when we measure our qubit, we will end up with a classical bit. Even if we had two of the exact same superposition states, we could get different results when measuring each of them. For example, with our skateboarder, if the eyeball appears two separate times, when the skateboarder is exactly halfway between the 0 and 1 locations on the ramp, it could find him in location 0 the first time, and in location 1 the second time.